complex macronutrients like carbohydrates, proteins and fats to fossil fuels like coal and petroleum, which are key to a nation's economy, carbon is present in all of them. But what helps carbon form compounds so readily? Carbon is a very important element of organic chemistry. A large variety of substances like the food we eat, the clothes we wear, the plastic goods that we use, the perfumes, the medicines we take when we are ill, and even the domestic fuels all consist of carbon. Carbon is a unique element as it can form covalent bonds with other carbon atoms. This results in the formation of straight chain compounds like butane. Branched chain compounds like isobutane and cyclic compounds like cyclohexane. The number of carbon compounds known to chemists was recently estimated to be in the millions. This property of carbon forming long chains with other carbon atoms giving rise to a large variety of compounds is known as catenation. Let us study the chemistry of carbon. In the periodic table, carbon is placed in the 14th group. Its electronic configuration is 2, 4, which shows that the outermost orbit has 4 valence electrons. This means it needs to lose or gain 4 electrons in order to achieve a stable electronic configuration. It would require a large amount of energy to lose these 4 electrons. On the other hand, if it gains 4 electrons, it would be difficult for the nucleus with 6 protons to hold on to these 4 extra electrons, making a total of 10 electrons in its atom. Thus, it is difficult for a carbon atom to lose or gain electrons to attain a stable inert gas configuration. It therefore does not form ionic bonds. Carbon overcomes this problem by sharing 4 of its valence electrons with other carbon atoms or with atoms of other elements like hydrogen. This makes carbon tetravalent. The shared electrons belong to the outer shells of both the atoms, and both the atoms attain the noble gas configuration, resulting in the formation of covalent bonds. Compounds of carbon which are linked by only single bonds between the carbon atoms are called saturated compounds. Compounds of carbon having double or triple bonds between their carbon atoms are called unsaturated compounds. Of the existing carbon compounds, compounds of carbon and hydrogen are called hydrocarbons, which form a major variety. Let us understand the bonding in each of the most common saturated and unsaturated hydrocarbons. For this, consider the formation of methane, which is one of the simplest saturated carbon compounds. Here, the carbon atom with 4 valence electrons shares each of its electrons with a hydrogen atom and forms 4 single covalent bonds. Both carbon and hydrogen thus acquire a stable electronic configuration. On the other hand, during the formation of an unsaturated carbon compound such as ethene, one of the carbon atoms shares 2 of its electrons with the other carbon atom, while the remaining 2 electrons are shared with 2 other hydrogen atoms. This results in 1 double and 4 single bonds in a molecule of ethene. As seen earlier, Carbon also forms bonds with other atoms such as halogens, nitrogen, oxygen, and so on. Let us study the formation of carbon dioxide as an example. During the formation of carbon dioxide, the carbon shares two of its outer electrons with each of the two oxygen atoms. This completes the octets for both the atoms and results in the formation of a pair of double bonds producing carbon dioxide. To summarize, carbon has 4 electrons in its outermost orbit. It does not donate or accept any electrons to acquire a stable inert gas configuration. Instead, it shares 4 of its valence electrons with other atoms forming covalent bonds. This property is called tetravalency. Carbon also shows a unique property of catenation through which it forms long chains with other carbon atoms. These two characteristic features seen in carbon, that is tetravalency and catenation, together give rise to a large variety of compounds. Like you just witnessed, carbon is the king of elements because of its ability to share electrons readily and form covalent bonds. But did you know there are different types of covalent bonds? Watch the upcoming videos to know more about it.